So yesterday in class, we talked about discrete and continuous functions. And here is a Frayer model of that. And we're going to do the definition, the graphic representation, which is over here. Then we're going to do how do you write it as domain and range. And then the applications, which just means examples. So as a definition, we want to come up with something that's a little more user-friendly than what we had yesterday. So maybe we could put down that it's points and they can be counted. And after that, maybe we can put down that the points are not connected. I hate that silence. But since I'm doing a video, I guess I have to let it be like that. Okay, so the points are not connected. If you can't see, here you go. If that's better for you. If you need to stop the video at any time, please do so because you know how fast I run. Alrighty. So let's do the graphic representation. That's on this side. I mean, I know it's a little far and it looks like we're not able to see it, but hopefully you will. I'm trying to zoom in. So these two graphs, one of them is the customer, and then it looks like, what does that say? I have no clue. Samples. Oh, yay, we're getting stuff for free. So here. This is a discrete function because they're points. Can we count it? Yep. We got 1, 2, 3, 4, 5. And then it also is for one customer, you get 2 samples. Dang, that's cool. I want some 2 samples like that. And these happen to be linear. And we could write these in y equals mx plus b form. We're going to talk about that next 9 weeks. Where m is your slope and b is your y's intercept. So if you have all 3, then you can find your y. So that would make 1 coordinate. Remember that you want to have coordinates. It's always an x and a y. Good? Awesome. Now we're going to go, how do you write it? So this equation thing, I was a little confused about, but I got it. It's, how do you write it? How to write domain, which I'm going to abbreviate D, and R, which is range, because I don't have enough room. So the domain and the range, they're always going to be written in one of the coordinate forms. So you got the x coordinate and you've got the y coordinate. So in class we talked about domain, that's your x. So you put the little brace, and then you would list your x coordinates. I pray I don't misspell anything because we know I do that often. Close it with another brace. Then your range, that's just a list of the y's. Notice I forgot the of in the x part, but that's just me. Now these 2 functions right here, one of them is like a scatter plot and the other one is pretty linear because it talks about the number of tickets and how much they cost. So that would make sense. That's a linear thing because each ticket is going to cost the same, and if you buy 1, it's a certain amount, 2 would double, 3 would triple, and so on and so forth. Now, if you look at this one, I'm a little weirded out because let's say this kid was at age 1, he was 1, 2, 3, 4, whatever that 4 means. But then look at here, at age 2, he shrunk. What the hey happened here? I don't know, but it's only an example, so let's not get all excited because I do. But this is kind of odd, unless they're using different people. Now, the last thing we have to remember about this is remember that the numbers that we have don't repeat. And what that means is, let's say you have a coordinate, and I'm trying to see if my paper will cover that. Let's say you've got 1, 3, and 5, 3. So right here, the 3's are repeated, but you would only write it once. So this is only written once in the range. Written once. That's what I mean by numbers don't repeat. Okay. Now, application. So these are your examples. And what does it look like? What it looks like. And we're talking the real world here. We're not talking about just numbers. We're talking about actual examples that are tangible to us, which means that we can touch them. So the first one, very easy. We talked about this in class, the desks in our classroom. Then the second one, maybe, the number of people on an airplane. And I'm running out of room again. Look at that. That's terrible. You can't even see what I said. There. Number of people on plane. So I'm making it really short. Then we could do something. How many white colored socks? So number of white colored socks. There you go. There you go. There's that one. And then how about the kernels in a bag of rice? You're going to be sitting there a while, but oh well, whatever. So that's what a discrete function looks like. Now the other video that I'm going to post is about continuous functions. And those we know are not points. So let's see how those are in the next video.